I'm gonna mute people. Unmute yourselves as if you want to ask questions.
Yeah, and if you want to ask a question, just jump right in and ask the question, or put it into the chat. And if you'd prompt me, Mike, that would be cool. And we can make some progress on this thing. So I sent out a PDF, and let's do this. I'm sharing my screen now. And okay, this is the PDF here. All right. So when we talk about ROS, we're talking about basically a publish and subscribe architecture. Okay, and I'm just going to go through some basics here. I'm opening a terminal window and I'm launching TurtleSim. That launches this little turtle on a screen here, okay? And then I'm going to launch something called teleop keyboard.
I don't see your screen. Is anybody?
Thank you for that, Jim. Let me make sure I'm sharing my screen. Sharing my screen. Okay, let's start it again. I am launching this sim turtle. It's a simulated turtle. And I'm launching something called teleop keyboard that basically allows me to drive the turtle around. Just look and see what's going on out here. Let's go ROS to node list. Okay, there's basically two nodes or packages running right now. The teleop turtle, which you see here, and the teleop turtle is the teleop keyboard thing here, and then the turtle sim is this simulated turtle here. Okay, so teleop keyboard is a publisher, sim turtle is a subscriber, and so this is the node teleop turtle that publishes and teleop sim subscribes. The messages that are published on topics. So ROS to topic list. These are the topics that are running. And you see a topic here called Turtle1 command velocity, okay? The command vel is where the teleop keyboard command vel is where the teleop keyboard tells the sim turtle to move. I'm going to open up one more screen here, and we're going to peek inside that topic, the topic command vel, okay? And we'll go ROS to topic echo slash, actually, I think I copied it earlier. ROS to topic echo slash turtle command vel. So I press that and you don't see anything. But if I come over here to the teleop and start working the keys, go forward and left and forward and left. And here you see the command velocity messages coming from the teleop keyboard publisher. So again, here's the echoing the topic command vel teleop. Here's the command vel teleop publisher, and this is the subscriber, the turtle sim. So when I go forward, and that's measured in meters per second, you see the x velocity is 2, positive 2. If I go reverse, you see the x velocity is xy linear velocity is -2. And if I turn right, you see its angular velocity measured in radians per second is -2. And if I turn left, it's +2. But the point is that I'm driving it around with these command velocity commands. Sure, it's a simulated turtle on a screen, no big deal, but this could be a physical robot. Also, the thing giving the command velocity doesn't need to be me on a keyboard. It can be some autonomous navigation package. BT Navigator, for example, can take command velocity and drive the robot around according to where the robot is localized, thinks that it is, and where it wants to go to. So that's all just a beginning thing. I think most of you guys already know this stuff. Let me exit out of this. Exit. And exit. Exit. You know, I think ROS is the best way to learn Linux. Seriously. All right, bear with me. All right, let me go boot up my robot real quick. All right, so why are we here? We are here to talk about something me and a couple of guys that are logged in here even have been working on, called the MockTurtleBot. And everybody's familiar with the TurtleBot. Okay, TurtleBot's a standard platform in ROS 2 for education, research, and development. It was created by our friends Melanie Wise and Tully Foote, and open source holds the trademark. This is its current iteration. The TurtleBot 4 is sold from ClearPath Robotics. It's made from an iRobot Create 3, which is made from refurbished iRobot or returned iRobot i3s, a Raspberry Pi 4 computer, and an RP lidar, and the OakD Pro camera. Now, and okay, this is the original TurtleBot was made on the iRobot Create. Okay, and then the TurtleBot 2 was made on a Kabuki base. TurtleBot 3, they went from being a floor bot to being a tabletop robot. I get it. It's educational, and you got to make money. So it's more of an educational product, a lower cost. But they've gone back to the floor bot form factor. And I really like this because I think it gets at what myself and others have a vision of a smart table, a tray table that can reliably get from one place to another. And so we've started a project. We're going to make a book called MockTurtleBot or TurtleBot, MockBot, something. And it'll be made mix and match kind of homebrew style, where you can use a Create 3 base, or you can use the BotVac base, or you can use just a regular iRobot Roomba. Or the Create, any one of those. And who are we? We are myself, Dr. Alan Fetterman, or Dr. Bot, Ross Lunan, that's Ross with 2 S's, and Phil McCrary, and Thomas Messerschmidt. You guys know us, been part of the Homebrew Club for a long time and other robotics clubs. And again, here we're building this personal robot. So, you know, personal robots. We've all, those of us of a certain age remember the Jetsons, and Rosie the robot was your general purpose robot, a maid, kind of to do the things that you didn't want to do. And I think right now where we are is basically the Roombas, the most common mobile robot in the world. And it's just a floor cleaner. But anyways, from there, in the category of the minimum viable product, is the TurtleBot, or a smart table, which is a human assisted robot where the tabletop is the end effector. It's not perfect. It can't navigate stairs. It can't open doors, but it could take things from one place to another. You could put a dish or a snack in the kitchen, send it out to the living room, the kids eat it and whatever, comes back to the kitchen, deal with the dishes later. I need my music to follow me around. I need my computer to come to me. You need something in the bedroom, you put it on the robot, and with a high degree of confidence, you can tell it to go there, and it ends up there. Or in an office, you've got something that needs to go to Joe's desk. You put it on the TableBot or the tabletop, the smart table, and it goes to Joe's desk, and pings you when it's there, and you can look around with the camera and see that Joe's not there, and then navigate over to Jesse's desk or somebody who is there, and then they can take the item. So it's human assisted delivery. I think this would be useful. We think this would be useful in the home or the office. So how do you get there? The starting place is with a workstation. I think everybody here is familiar with ROS. And you just download the image and restore it to a thumb drive and boot off that thumb drive and install Ubuntu, and it's pretty straightforward. I picked up, I think this is I think this is actually an i7 process, maybe it's an i5, but anyways, you can get these computers from Goodwill for 150 bucks, and it's perfectly adequate for running ROS. If you get the workstation going, you're going to need to get the workstation going for the end goal, that is the smart table, mapping and navigating, a tray table that can reliably get from one place to another. But the starting place is your workstation. So, get a ratty old virus infested Windows computer and blast it with Ubuntu. Oh, by the way, in trying to solve a problem, we recommend, the mockers recommend, you guys join in it here anytime you want, Alan or Ross or Phil or Thomas if you're out there. But Ubuntu 2204 and Humble seem to be the best versions today. It's a long-term service release, good till 2027. And I was having trouble and thinking go to 2404 Jazzy Holico, but I've discovered a stop in the road where they haven't even ported nav2 over completely, so forget that. Anyways, I resolved the problem, and I'll probably mention it again later, but it was by launching the launch file from a different package, which had a different set of parameters. But regardless, get yourself a good workstation and blast it with Ubuntu 2204 and install Humble. If with just a workstation, you could do things in Gazebo. There's a beginner editor. It's pretty decent. You go in there and build things. And this is, the real goal is to get to a physical robot, but there's things you can do in there with just the workstation and setting up the URDF, the Universal Robot Description Format. These are things that we're dealing with now and trying to produce this book. It's like if you want to mix and match faces, lidars, cameras, other sensors, you've got to put it together in the URDF so it makes sense even as it's trying to navigate, and it makes sense within the visualizer ARGIS. So that's all this URDF stuff. Anyways, the point here is these are things that you can do with just the computer. And really one of my favorites is Lino Robot. Some time ago, the Homebrew Club had this big long list about creating a standard ROS-based club robot. And we talked about this, that, and the other, going here, there, doing this and that. But this Lino Robot kept popping up, okay? And we spent quite a bit of time going over the Lino Robot. And at the end of the day, it's like, if you want a standard, ROS robot, the Lino Robot, is what that should look like. I'll put this in the chat, by the way. And so the Lino Robot's really great and an example of something that could be done with just the workstation. Questions, comments, complaints?
Yeah, I guess I could, my contribution to the group is I'm the one building the original, building on the platform of the original TurtleBot. I'm taking the 2010. It was originally coded into a Ubuntu 12, I think it was. And I am using the Lino Robot as a template to build the code to actually drive the base and the handle, the transforms, and
do you have that model handy?
As I actually do. I was actually running I was teleoperating it around my basement.
I'm talking about the RViz.
Oh, the one that I was successful
Is that what you're talking about now, or are you actually talking about your physical robot?
I'm actually both.
Okay.
The physical robot works just fine, teleop, and with the next
Can you
step
show us
is,
the robot?
pardon me?
Can you show us the physical robot?
Sure. Um, uh, talk a little bit and I'll turn on the lights. Actually, it's easy to do. There won't be any, let's see, I'm connected to a cord here.
Don't hurt yourself.
There we are. Look, there goes the light. And there's the coolest feature on a Mac that if I turn on my phone, turn on the camera, and then run photo booth. Photo booth app. There it is. Okay. So I'm going to share my screen.
Let me stop sharing mine
Um,
and let me allow screen sharing.
okay.
Go for it.
There. Okay, that's me, right?
Yeah, that's you.
Okay, this is sort of hard because the robot's over here. But there it is.
Awesome. That's Turtletron?
Right. This is called, yes, Turtletron. I actually came up with that name by AI came up with the name, but to go in a little closer. Okay, so there's the crate base. Some will recognize the circles and the standoffs. And inside is an assembly I put together that mimics what's on top of the TurtleBot 4 base, which is an assembly of the RP lidar, the OCTI camera. I am put in a 9250 MPU 9250 IMU right at the top of it, and it right now I've got actually the drivers for all four of those things working just fine, and my next step is to incorporate them into the static transforms to actually
Ross,
do
I'm
something
gonna
useful.
go back. Ross, I'm gonna go back to the presentation, but if you could get your RViz and the URDF spun up, that would be cool.
Sure.
Hey,
Okay.
by just looking at the size of the RP LiDAR, and this is one I just got. It's a YD
Uh-huh.
LiDAR 19. And you see how small it is. And supposedly this one's good for 12 meters.
Does that come from the same folks that do the LD06?
I think it is the same people.
You say that's an LD 19,
LD19.
LD
And the
19?
company is
Innomaker?
UE2.
Nah, Innomaker makes the other one.
Yeah,
Anyway,
and
let's
it
get back to
works
the
pretty
let's get
well
back to the presentation here.
out of
All
the
right.
box.
So the point is, let me share my screen. The point is that just with the workstation, there's lots of things you could do with ROS. Go through the tutorials, get into the gazebo editor. You can do the URDF stuff, and also the Lino robot here is a good thing to work with just with the computer. So after you've got a good ROS workstation, you need to build the robot compute. When I originally wrote homebrewed robots, I routed you to the Ubuntu page for Raspberry Pi. Now when you go there, it wants to install 2404, and I couldn't find any way to get back to 2204. You don't want to 2204. You don't want to use 2404 because then you have to go to Jazzy, the next version. And like I say, nav2 is not ready on Jazzy. So the best way we found to do the Ubuntu 2204 is to go through the Raspberry Pi imager. So here, assuming you've got a Windows workstation, you would use, Windows, I think it's called Disk Manager or something. I really I really couldn't make heads or tails of that. I downloaded Rufus, and I used Rufus. You take your ISO download and you burn it onto you burn it onto a micro SD card. Actually here, when you get to the Raspberry Pi, you're not using Windows anymore because you've already made an Ubuntu workstation. So here you can do disk writer, use GNOME's disk writer, but then you image to the micro SD card, and we recommend that you connect that to. We're actually using the desktop because it's the easiest to attach to the network and password instead of doing the server version, having to deal with NetPlan and all that stuff. So you create the ISO image desktop Ubuntu 2404. You have a workstation and keyboard and mouse, and you boot it and get it onto the network and play 20 questions. And thereafter, you can SSH to it. In fact, you should install SSH at that point. But given that you've got a Raspberry Pi with Ubuntu and SSH, you can install the ROS either while it's connected to the monitor, or you can install that headless. So here I've taken a Raspberry Pi with Ubuntu and put it into the BotVac. BotVac has a micro USB port, and you can drive it, read the lidar scans, and so forth. The cool thing about the Create 3 is that it's got ROS 2 built in. So, for your $450, you boot it up and it runs all these ROS nodes, exposes all these topics. You still have to, get a lidar for it, which is another $100. And like I say, you can get BotVacs through eBay for, less than 150, and it includes the lidar. So this is arguably the best value, but we're talking about building TurtleBots in a variety of ways. So speaking of which, it's all about the base, okay? We're going to build these MockBots using the Roomba Create 3, which, like I say, if you've got the wherewithal, this is really the best way to go. The suspension is phenomenal. You boot it up and it's running ROS out of the box. Hardware. Yeah, it's like even the bumpers and stuff, it's got actions in it. So even as you're navigating around, it can sense if you bump something left, right, center, it backs up and turns the opposite direction. They have action commands for docking and undocking and wall following and stuff like that. So, I mean, it's really nice to think in ROS that, you could navigate to near the docking base and then just execute this docking action, and the robot autonomously docks. So, those are nice things built into the Create 3, not to mention this is what the TurtleBot 4 is built off of. TurtleBot 4 sets you back $2,200. Understandable. It's like $1,000 parts list. You look at $450 for the BotVac. You look at $100, $200 for a high. Actually, they got the Oak D Pro, so it's $300 for a 3D camera, and $100 for the lidar, another $100 for the Pi and the camera, and those are the Pi and the battery. So it's $1,000 parts retail. They got to make something off of it. So $2,000. Even as you build up, a MockTurtleBot with the Create 3, you're going to have pretty good investment versus a BotVac. If you got that with a camera, you could probably build a TurtleBot for in the range of $300. So that's actually the best value. Let's get back to this.
They were selling the Create 3 base for my robot as a bundle for $350. That's what I just got.
Let's see. Create 3. Am I still sharing my screen?
Yeah.
Okay. Shop now. So there it is. Normally $450. Yeah, here you go. you got the $350. So it's on sale for what, $100 off? And they throw in an extra cargo bay and an extra faceplate. So again, if you're interested in doing this stuff, easy for me to spend your money. I think the Create 3 is the way to go. Otherwise, the bot vac, is the best value. So let's get back to this. So here's a Create. This is the Create 3, and there's the bot vac. Okay, like I say, it includes the lidar. And then here's just a plain old Roomba. If you got a Roomba laying around, pop the lid off of it. You'll see a 7-pin mini DIN. That plug can be bought from that interfaces Amazon. Let me know if you're interested. And Ross, you got something going here. This is your retro Create, right?
Yeah, that was the first attempt. Actually, I was following Sergey's code and whatnot, and I've built on this from there. By the way, I've got my URDF working. Showing.
All right, let's go. Shout out to Sergey there. All right, I've stopped sharing. You go ahead and share, Ross.
So this is the URDF that is built from a combination of most of you will recognize the circles. This is a Create 1 base, which is a Roomba 500, and this is the pieces that are part of the TurtleBot 4. And this little bracket here is actually a copy of copy of the bracket that holds the camera from their own drawings.
Didn't you make that out of spoons?
Huh?
Bent spoons?
I guess you could, yeah. No, I built it out of.
I'm trying to be funny.
Yes. Whatever. Anyway, here it is. This is something I probably took me 3 months to do, but now that I have it, I can then start to mess with the static transforms and go from there. The URDF for all these circles and stuff is quite huge, but interestingly enough, it's the 14-year-old XML file works just right when you interface it properly with the other stuff that make it work. Anyway, I know a whole lot more about exact rows and macros and XMLs than I thought you could learn.
He's our exact row expert. So it's all about the base. And so, yeah, 3 different bases, Create 3, bot vac, or Roomba. So after the base, it's the tabletop end effector. Okay, here's my lineup here, the Smarty lineup, Smarty 1, 2, and 3. There's a bot vac, a Create 3, and this is a regular Roomba. I haven't outfitted it yet, but we're getting there. Here's Thomas Messerschmitt.
You're not sharing your screen anymore.
Share my screen. Thank you for that. Let's take it from the top. So after you've got the base, you need a tabletop end effector. And this is my lineup here, Smarty 1, 2, 3. That's bot vac, or Create 3, and a regular Roomba. And then this is Thomas's Rosie smart table, and one of Alan's smart table. I think what Ubiquity's got a cocktail waiter table, don't they now? Alan, don't I see a cocktail waiter version of the robot from Ubiquity? Anyways, here's some others. I like this one. Magni table bot. Technically, it's a floor bot, but that's okay. Shopper, helper. Gopher. Any of you HBRC old timers remember Gopher, general purpose home robot, right, Alan?
Sort of a
Alan,
joke.
Yeah, there you are.
The gopher, the idea is, so I was out of work at the time, so I had a robot that could push a broom and flip a burger.
Yeah, your audio is really crackly, dude. But this is
Okay.
there you go. Here's Gopher.
Why are you showing these things? They're
No, I'm showing
embarrassing.
table bot. I'm showing smart tables.
Yep.
So there's the, again, the concept is a human assisted delivery. Of course, here's your original tray table. Okay, and then a chapter on lidars, the Nito BotVac lidar, the RP lidar, and the DL06 lidar, which is very small. That's a quarter there. Did you say the DL19 is even smaller?
I think it's bigger.
Okay, but this is a really an amazing small lidar, and what's the price on it? It's only $100, I believe.
Kind of depends on the week.
Yeah, there you go. LD06. Anyways, I'm a big fan of this one. It's the one I use on Smarty too, and it's really good.
Yeah. That's a quarter compared to.
It looks like they're the same size, DL06 and
Yeah,
DL19,
pretty small.
roughly the same size.
It's really weird. You think the front would be this way, but the front's out the side. That's the front.
Of course. All right, cameras and other sensors. We want to put the OAK-D light on there. Interesting enough, is looking at the TurtleBot 4. I don't think they've actually implemented the depth camera on this thing. I think they're just using RGB, and so there's an
Yeah,
opportunity.
that's correct.
Because with the smart table, you do the mapping with the lidar, and you do the navigation with the lidar. Actually, you'll need some kind of sensor for navigating, depth camera or ultrasonics to cover the mid part so it doesn't navigate under the bed and under the couch. But anyways, we'll do this again, homebrew style, mix and match, your choice base, your choice lidar, your choice camera, and try and put it all together. So we're talking OAK-D light camera. Here's the Raspberry Pi camera. Alan, do you want to talk about Pi cams?
Yeah, actually, I've struggled a lot with getting the PiCam to work when they went from 20 to 2004. The reason being is we were using something called MMAL, which was based on 32-bit C. And when they went to 64-bit C, Raspberry Pi stopped supporting MMAL. They still have a way to do it as a legacy in the config.txt. You say camera auto detect, change it from 0 to 1, and then you can go, except now where you had to build all the code, you can get it through a sudo apt install to install the camera. So where it took me 2 years ago 6 months to get the camera to work, it only took me 1 day to get the camera to work with ROS.
Well, the funny
Except
thing
when I
about
first did it, when
it
I
was
first,
the PiCam was so simple on ROS 1 and it just worked.
Yeah.
yeah,
And then we went to ROS 2 and went around the horn.
yeah, but now it's easy again. The only thing is the default is there. It's 3400 by 2800 pixels, and when I first started up the camera, I was getting nothing. And then so I'm looking at RQT image view, nothing, nothing, nothing. Then all of a sudden, around 2 minutes later, I get an image, and I say, "Oh." Then when I reduced it by 90%, you can actually get data. However, even that, you can barely use it as a navigation camera. It just there's so much data in images, even if you put it at, 10
Well-
frames per second,
Preliminarily,
340
I was just doing remote viewing, and this is what made me go with just the Logitech and the regular USB
Yeah.
video Linux stuff.
I have very large concerns about using an AI camera unless you're going to have it on a separate processor. It's just too much data on the network.
All right, hang on.
For
Let's
home.
get back to the presentation here. So we're talking cameras. There's an Oak-D camera, Oak-D Lite's probably the best value. We got the PiCam, Logitech camera. I've got a Logitech camera on mine. Mine's just for remote viewing currently, but we need some kind of sensing to guard the belly so the robot doesn't bump into stuff. Here's where in the Ross discussion group some time ago, thanks to Mike Wimble and was it Marco, I believe, Ralph Ganock may have been involved, but we created a homebrew ultrasonic sensor package. If there were an ultrasonic sensor package at the time for ROS 2, I'd have used it. But what we did basically during a ROS discussion group is we went into the ROS Simple Publisher tutorial, and we took there was a program that a Python program that ran on the Raspberry Pi, and the Python program would basically generate a variable called distance, and we basically took the Simple Publisher program and instead of publishing text hello world, we published a range message named distance, which was the variable that came from the Python package. I guess that would be our driver. And then we made this homebrewed wrapper, if you will, that took that variable and published it as a range topic, and it actually functioned. Here you can see the URDF with the range cone when the sonar sensed an obstacle. So, some way, shape, form, you've got to cover that belly of the smart table so it doesn't navigate under sofas and beds and so forth. And so, again, this is about creating a TurtleBot, a MockTurtleBot, if you will, a MockBot. And we're using it's human-assisted delivery. And you make the workstation, you make a Raspberry Pi to be the computer for the robot. And then, again, create 3 BotVac or Roomba. Put a tabletop on it. LiDAR de jour, XV, RP, DL, camera, Oak-D, PiCam, Logitech, sonar sensor, okay? And now you've got to put it all together. You've got to put it all together with SLAM toolbox to create your map. You need to be able to save your map. Then you need to load that map in. You need to load in your localizer, AMCL, generally adaptive Monte Carlo localization, and RViz is the visualizer. This is the world as the robot sees it. So this is the SLAM map driving around. And then I've loaded the map in with nav2 and the camera also, and navigating around. And so let's see, without any further ado, I shall get into our demo here, all right? Is it questions, comments? Are we having a good time? Is this worthwhile?
Yep.
Hey, Jim, how you doing?
All right, pretty good.
Very good. Hey,
It seems
Vezin.
like so much deja vu from what we did at SV Ross God, what was it,
Mm.
6 years ago, 7 years ago?
Well, you do it enough times and we'll eventually get it, won't we?
Yeah, make a map and run it,
There
let
it
your
is.
bot run out the door.
This is built from the SB Raw stuff. Mike Ferguson in 2010 wrote the original Nito package. And you guys in SB Ross, also around 2010 must have been. And you had the NASA challenge. We don't talk about that though, do we, Matt? Do we, Greg?
Oh yeah,
But,
we love the NASA challenge. We just
um,
came so close. And Gertz is, a genius at this stuff, so I don't know what he's up to.
yeah. Well, yeah. Oh, anyways, but yeah, and then you guys work, and James James has updated the code to Python 3, and so I'm still running the same botvac package with the nav2 stuff, and so that's where we are with it. In fact, let me share my GitHub there, Matt, Greg. Yeah, Greg ran the SV Ross group that did the original botvac package on the XV and had classes on it and everything. It was awesome. Good times. Alan, you were involved with that too.
Yeah, guilty as charged.
All right, so let's get this party started. I'm first going to run teleop keyboard here.
You
If you have a
see
question,
the text error there, where it says, out in the middle, it says this launches the DL06, should be LD06.
oh, thank you, man. LD06, LD06. This, you talking about this? Oh, here.
Next line, yep.
Somebody's dyslexic.
This is thank you. I'm going to thank you. Okay, so we've got the keyboard going, and oh, I know. I need to navigate out to the Pi that's in the dirt bin. It's named Corey. And here we're going to kick off the lidar. Remember the Sim Turtle lidar you kicked off? It's a public yeah, well, that was the command velocity. Basically, this is publishing the LiDAR scans. So I can open a terminal on my workstation and ROS to this command line, topic, echo, /scan. These are the scans from the LiDAR, okay? It's running on the Pi that's in the robot, but I'm viewing the scans. They're being published. I'm viewing them on the workstation. And so there we're launching the LiDAR. Okay, now I'm going to launch bolts. I was copying and pasting on this too fast. I want to go back to my original cheat sheet. So now I'm going to launch Slam Toolbox. And I'll launch the RViz, the ROS visualizer. So here it should bring up the robot, and you can see the robot, and you can see the map scans in there. And let's drive it around and make a map, okay? Bring up the teleop so I can drive it around. This is the same thing we did with the TurtleBot sim, except I'm doing it with a physical robot. That is, I'm publishing, actually, let's look. I'll come up here and say ROS2 topic echo / command vel, command velocity, okay? Oops, vel. Okay, there's nothing there yet. Okay. I'm coming over here to the teleop keyboard, and I'm going to drive the robot around. Okay. So it's actually creating a map, okay? And so again, you'll see that when I press the key to drive the robot with teleop keyboard, it publishes a command velocity message that the robot is subscribing to and that drives the robot. So let's just go forward here. And you can see that X is 0.5. Again, this is meters per second. So I'm driving the robot around with the keyboard, nothing fancy, but it's creating a map as I drive along. Questions, comments? Demo's going too well. Something's got to go wrong.
What are those little black specks it's leaving behind there?
Good question. Those are the legs. The
Oh.
table. Those are the table legs.
It's
I didn't
leaving
see it.
imprint.
Yeah. I'm going to clean that up before we actually start navigating.
All right.
You've come a long ways since we did this 7 years ago, 8 years ago.
Yeah. It's getting, well, you know, 7 or 8 years ago is a long time ago. It's about damn time. Yes, it's leaving little breadcrumbs. Now, if I had navigation on, I could put a circle around that and they wouldn't come out. What's that called? Robot radius in the parameters.
Yeah.
Oh,
But I don't have navigation going. I'm just doing pure slam here, slam toolbox. So
There's
again, this
also
is,
something called radar filter that you can filter those out.
can you do that in slam toolbox?
The filter is a YAML file on the lidar.
Uh-oh. My map's going to get really screwed up here. Something's offset. So this is where when you create maps. Oh, whoa, no, it's foobarred. When you create maps, when it's good enough, you should call it quits. This map's foobarred, but that's okay. I've already saved a good map, and I'm going to use the good map. Oh, look at that! Wow, it fixed itself. I am impressed with Slam Toolbox. Usually that doesn't recover. This is the bathroom. Wow, usually it doesn't recover. The point there is that as you make a map and you're driving along, good enough is good enough. Make frequent saves as you go along. Otherwise, you're going to bump into something or something's going to get foobarred. And usually when it gets offset like that, it goes really bad. But anyways, that was a good one. Okay, let's come back into the lounge here. Coming back into the lounge. Okay, the robot's back here at home base. Robot's back at home base. Let's see here. Test 1, 2, test 1, 2. There's the robot is back in the lounge. Okay. And so what we have right now is a map. We've driven around and we've created this map, okay?
So what's
I
causing
feel
those openings that, right in front of it? Is there some sort of reflective surface or something?
You're talking about in here, down here?
In the right above there, I have no idea what you're looking at. I don't see a cursor.
Yeah, it hasn't seen that. I have to get back into the crevice here. So it hasn't seen behind that wall. You understand what I'm saying?
There's something there blocking it, you mean? So it's seen
Well, yeah, it's
under
tight.
it, or,
It's tight. It's tight. It's tight.
or is it like a mirror or a window or
No,
something?
it's tight. Bear with me.
All right.
Here. Okay, you see where I am? Okay,
Yeah.
around in here. Okay, let me drive in there now. And
Oh,
I'll
I
get
see.
it.
I got you. Okay.
It's tight. There's a wall in front. I'm not looking behind it. So the robot
Yeah,
does
you
not
got a
know
lot of
where
stuff
that is.
in the way. Yeah.
Yeah,
There's
yeah, I've got stuff.
obstacles.
I don't plan on navigating back here, so I don't really care about this. But I'll drive back here and there we go.
Camp, just an observation. That mapping problem that you are having, it happens when the robot turns. And then things kind of are misaligned and mapping fails. What I observed before is that on my robots, it happened when I had odometry and IMU not working perfectly. So if your wheel's diameter, your wheel's base is not correct, or your gyroscope is not delivering the right data, that's when mapping has problems in the turns.
It's also true that in his navigation.yaml file, there's a section in there that models the noise from the lidar and the wheels, and he hasn't changed the model values, last I knew, from the default ones that come from the Git, but you can change those and it'll sync a whole lot better as you drive. I'm actually writing a paper about that.
All right, I'm saving the map. It has successfully saved the map to this location. I want to navigate out and get those dots out of it. Think now. Home, ROS 2, SRC, RC maps. Opening it with color paint. I love color paint. Uh-huh. Is that it? Yes. Okay, and that may make it fit the page and get the eraser. And these are basically the table legs that are on the robot. The scanner's in the middle. It sees it as an obstacle, which is a problem, but I'm just creating the map. And yeah, I can go in here and clean up the map and it'll be fine. When you're navigating, there's a parameter called robot radius. And you define that and it'll ignore anything inside that radius. So it'll ignore the table legs when it actually navigates. Clean up these specs. All right. Saving the map. All right. So here's RViz. Let's exit RViz. Get this too. Go on. Go that. Okay, so we've driven around, slammed toolbox, created a map, and now we want to navigate within that map. You just get a fresh start here. All right. All right, nothing up my sleeve. Let's get back to the okay, one more time. I'm going to run the teleop keyboard in case I need to rescue it. Shouldn't have to drive it around now. I should be able to navigate autonomously. Next, let's run the localization routine through the TurtleBot 4 package. That loads the map, it loads AMCL, and it loads lifecycle. And now we're going to launch the navigation stack, which loads your local controllers and global planners and recovery behaviors and et cetera. And then finally, we'll launch the RViz, the ROS visualizer again. This should load in the map that we've already created. I'll need to, where the hell did you get that map from? That's not it. That's not the map we're looking for. Let's look at this one. Let's do this one. Oh, you file. Open configuration. Let's see here.
These are not the droids you're looking for.
Yeah, I haven't had this map come up before. Let's see. Let's see here.
Did you log into the?
Oh, I wonder. Let me back out. I must have loaded in the wrong map. How'd you expect that to work? What's the question?
Did you log into your robot in each one of these? Because I didn't.
The only thing you have to log into is the Pi for the lidar.
You don't.
The computer that's on the robot, the iRobot, it's already running, and then you're running a workstation. So let me
What are
provide.
you running? Aren't you running like the navigation and the localization on the Pi or not?
No.
You just
Basically, yeah, let me explain. Is there's the iRobot, which is the main board in the Create 3. There's a Pi called Corey that I run my lidar off of. Okay, and then the workstation is called Goliath. This is the workstation. I'm picking myself. Okay, so those are the three variables. I'm
three.
going to run and start at this again. Is keyboard to drive it around. Okay, I want to run the nav to bring up. Nav to bring up. That's what I want. Okay. I want it from this. No, bear with me. I want the TurtleBot version of this. I don't want the nav to bring version of this.
So you're running that on your laptop, this
I'm
Goliath.
running this on the laptop.
Yeah.
The robot has its own compute. The lidar has a Raspberry Pi, and then you've got a workstation. And what I'm wrestling with here, and I apologize, is the thing I discovered the other day is launching it from the TurtleBot package versus running it from the nav2 package. It uses different parameter files. In particular, the nav2 package was using base footprint, and the TurtleBot package was using base length. And that's why my scans were all out of sync and didn't transform to the map. So this time I'm trying to launch, bear with me, I just want to check something. ROS to topic echo / scan. Okay, I don't have scans coming through. So let's do this. Let's SSH to Corey. Yeah, SSH to Corey. This is the Pi. Home. This is the lidar.
Could you have run? Can you? I guess it's good to have two CPUs like that.
This is on the workstation. ROS to echo / scan. So ROS to echo.
Help it.
So you see the scans coming through here. I want to run the Lamb toolbot. I want to run the TurtleBot localizer. That's what I want. Okay, and I've got the right map in there. Okay. So this is run on the workstation. I am running localization on the workstation. Localization runs the map server, AMCL, and lifecycle. And I'm also running nav2 on the workstation. That's the
All right, that makes it
oh,
fast.
that's the local control. Yeah.
That's why it's
And
coming up
finally
fast.
here comes the RVs. What's the question, Jim?
No, I'm saying that's why it looks a lot faster launching than mine because you're running on the workstation.
Okay, so here's my map, and I have to set my pose. And I'm basically sitting here and I'm going that way. And so here you see the transforms, you see the lidar scans, you see a local cost map, and you see a global cost map. Let me navigate a little bit, and it should localize better. I'm just going to spin. I'm just spinning it with the. There we go. Get to the goal. Doesn't seem to be localizing very well. Let's see if I can navigate. There we go. All right, let's go all the way to the kitchen. Let's push our luck. I'm going to crank up the camera. SSH to Corey again. This is the Pi inside the Create 3. I've got a camera attached there, Logitech C270. And so this sets it at 5 frames per second, which is good for remote viewing. And then there's your camera driver. And we'll turn on image here. And there's the camera. So let's navigate back. Here's the robot going down the hallway. Nothing up my sleeve. Getting a little delocalized there. Let's see how it does. There it goes. It pulled in nicely. All right. Well, let's do a double-decker TableBot challenge. So I'll do navigation 2 waypoints, nav 2 goal, 1, 2, 3, 4, 5, 6, 7. Let's go into the bedroom and to the lounge to end it up. This is like a quadruple floorbot challenge. That's some recovery behavior there. That's interesting. If you watch the nav2, here it is. This tells you what it's doing. So the nav2 here tells you what it's doing. Also, here's a handy little utility, nload, and you name the Wi-Fi adapter. That's the Wi-Fi adapter on my workstation so that you can see the load going through the network. Here, incoming 6 megabits a second. If that video were not compressed, it'd be like 40 megabits a second. Yeah, so this is nload on the workstation. That's the input coming in, traffic on the Wi-Fi card on the network. And then let's SSH back out to the Pi. And same thing, nload. WLAN 0 is the Wi-Fi adapter. And so here you see that it's outputting like 3-4 megabits a second. That's the same 3 or 4 megabits a second going into the workstation. If the video weren't compressed, again, it'd be like 50 megabits a second. So yeah, here you see the image raw compressed. If I was using just the regular image raw, it'd be like 10 times the traffic. What's wrong, robot? Let's give you a hand. Let's actually look at the running weight. These are recovery behaviors here. Looked like it may have, no. It's supposed to be spinning. I don't see any spinning behavior. I think it thinks it's too close to that wall. Okay, okay, so okay, here it comes. I just needed to help it a little bit on that spot. So let's pick back up the trail. Questions, comments?
What do you do if it gets stuck, like bumping into something and cannot move forward anymore?
Well, hopefully that doesn't happen. If that happens, you're no longer navigating. Now you're into recovery behavior. So again, the point here is that with our 2D lidar, we've created a map, and we've saved that map. And as you can see, it's navigating through the map pretty good. Okay. If I had an obstacle, for example, I'm going to stand right here, and it's supposed to drive through me. And look at that, it went around me. Okay. So it's obstacle avoid, but you know that's 2D lidar. It's only 4 inches above the ground. It's only a horizontal plane. So I do not have anything covering the center. Also, what's nice about the Create 3 is it's actually got some reflexes built in. It's got some actions on the bumper, because even now the lidar, if I bump that, it backs up and turns the opposite direction. That's a built-in action in the Create 3. That's just part of the Create 3 when you boot it up.
So Sergey, the behavior is driven by a behavior tree. That behavior tree has recovery behaviors and retry behaviors. And if it bumps into something and gets stuck or something, it has strategies like back up, spin around, things like that. And it retries it a few times. And if they all fail and there's another component that checks, are you making any progress toward the goal? And if it finds after a short period of time that you are not making any progress, it just aborts everything. And the guy who originally requested that the robot move somewhere gets a notification that the request has failed, and it's up to you to take action then.
Yeah, me getting in the way of it here got it off the path. And so actually we're seeing some recovery behaviors running on the nav2 down here. You see running weight, that's a recovery behavior. Spin is a recovery behavior. Backup is a recovery behavior. It's trying to relocalize. He's struggling. I don't know if he's going to get back on track. I'm going to help him with the teleop keyboard. I'm going to turn him this way. And I'm going to drive him that way. So I'm driving it with the keyboard, but I'm hoping that it'll relocalize. See there, it's localizing now. You see how the scans are getting in line with the wall? Okay. And now he's finally coming into the lounge here. So that's actually the end of the run, even though he didn't go the full path. But that's it.
Yay.
Thank you. Thank you very much.
Well
Question?
done.
That was pretty chancy to make it run the same route several times in a row.
Well, the tricky thing was adding the video. I was doing it, but I installed the compressed transport, and first time it didn't work, but the last time I booted, all of a sudden it was on compressed transport, and you saw it, there was only, a couple of megabits a second, whereas when it was not compressed, man, it was 50 megabits a second.
Yeah. If you go in again to your navigation.yaml file, there's about 6 parameters you can adjust in the AMCL section that'll help it not lose localization so often.
Yeah.
Of course, if you smash into something and those wheels spin and the robot doesn't work, then if it spins long enough, it'll have a hard time recovering.
Next week, let's do, your thing on parameters. Let's go through parameters, because I found the mishmash between TurtleBot parameters and nav2 parameters, but still needs refinement. And yeah, it's good stuff. I'm going to go ahead and stop the recording if that's okay.
Yep.
All right.